Now in this segment, we're going to show you an exercise you can do with your students that's designed to illustrate the importance of thermal radiation as a means of energy transfer. So we've got two cylinders here on this hot plate, and this one's shiny, and this one's painted black. And Sheila knows how they're made. How did we make these?
We cut aluminum rods into about 1.5 inches or 1 inch length, and then drill a hole in the center so that we can put the thermometers in there. And the black one is sprayed with spray paint, but this one is left as raw metal.
So bare metal, and this one's painted black. Now, if we look at these two things on the plate, there's a surprise. They're both sitting on the hot plate. The hot plate is at the same temperature on all the different parts of the surface. But tell me about the temperatures of these two cylinders.
This one is warmer.
This one is warmer.
Which surprised me.
The silver one is warmer.
Yes,
what?
Than this one.
Than that one, which is kind of crazy. Like, why would that be true? We're going to leave that mystery open for a second. Next, what I want Sheila to do is to take these two cylinders, move them off to the side, and we're going to put them on this little hot mat.
And they are toasty, so we have these gloves
to help
for the students to use. So you can take those off.
And then what we're going to do is we're going to monitor the change in temperature.
That one wants to tip.
With time.
Okay.
And this is a good exercise. This can take 10, 15 minutes to do this with your students. And if I look at this one, I can already tell this one over here, the black one, is dropping more quickly. It was cooler, but this one has already dropped a full degree since taking off, and this one has dropped about 0.5 degree since being taken off. So the black one is actually losing heat more quickly. It's cooling off more quickly.
Wow.
What?
That's a surprise.
Students don't predict this. What
No.
will students say?
They'll think that the plain metal is the one that will cool off.
Because this one has like a coat of paint on it and
Which
coats.
we usually think are insulators, right?
But if I look at it with the thermal camera, you can see the difference between the two. And actually, I'm going to focus this in. And here's my two cylinders. And Sheila, take a look at these on the thermal camera. This is fantastic. The one on the right, this black one,
oh man, it's white.
It's glowing.
It is glowing.
It's emitting ridiculous amounts of thermal radiation. And the temperature that we read is 71.2. Now, check it out. This silvery one over here is not glowing at all.
It is not.
And it reads a temperature of 34. But if
Yes.
we look at the thermometer stuck inside it, we can see it's up in the upper 70s.
You're right.
So it appears cooler. The reason it appears cooler is it's not emitting very much thermal radiation. And what the camera does is it uses the emitted thermal radiation to determine the temperature. So for the cylinder, this is a very, very poor way to determine the temperature. It looks like it's cold, but it is not. This aluminum one is hotter than the black one. And the reason it's hotter is because this black one over here that's shining so brightly, this black one is giving off tremendous amounts of thermal radiation. I can feel it. If I put my hand near it, you can feel it.
Oh yes,
it's radiating
you
thermal
can.
energy. Whereas I take this one, I put my hand near it.
I want to touch it. I know
wanna
I
touch
can't.
It. It's really hot, but it's not radiating thermal energy. I don't feel it. I bring my hand near it. It's like not feeling a thing, but then I touch it. Ow! And now it's definitely hurty. It's definitely hot enough to be hurty, but it's not radiating thermal energy. And since it's not radiating, it doesn't lose energy as quickly. And if we look at the readouts here, the black one is now a full 10 degrees cooler than the shiny one.
Wow.
They were 3 degrees apart when we took them off the plate. The black one is now a full 10 degrees cooler. And it's just dropped in temperature because it's emitting more thermal radiation. So these two things are the same size, they're the same mass, they're identical in every way except this one was painted black. And being painted black means it's a very, very good absorber, but also a very good emitter of thermal radiation. And as a consequence, it's sending energy out into the room, cools off much more quickly.
I like that.
It's awesome.
Similar to the Earth then.
Similar to the Earth. Now, I want to show something kind of like awesome with this demonstration right here. If we take this thermal camera and I look at these cylinders, we're going to go ahead and switch all the lights off except for one so the room gets nice and dim. And if we do that, I want you to see how the view changes. And what changes is nothing.
No.
The energy we're seeing is the energy that they're emitting. Now we're in dim light. But as far as the thermal radiation is concerned, nothing has changed at all. Because it's just, we're seeing not light they're reflecting, but light they're emitting. Just like the Earth. You could see the Earth, the surface of the Earth, anytime, even if it's dark, because you're seeing energy that's emitted. And that brings me to my favorite thing to do with the thermal cameras, hide and seek. Because you can do hide and seek in complete darkness. Because if I'm looking for Sheila,
Wait. I don't know where to hide.
there's nowhere to hide. Because
No.
even if it's completely dark, I can see the thermal radiation that she's emitting. And so there's nowhere to hide. There's nowhere to hide. The only
Shoot.
way you can hide is to be the same temperature as your environment. If you're the same temperature as your environment, you're dead. So that's not helpful. It's not helpful. It's kind of a crazy thing. So I've done this before at Halloween time, where we went outside with thermal cameras. And not only could we tell where someone was, we could tell where someone had been.
Oh, wow.
Because
Yes.
if you sit there for a while,
Uh-huh.
you leave a warm spot. And we can see footprints across the grass. So it was like, you can't hide if we're doing this. And that's just kind of an extra fun, it's an extra fun thing.
Definitely. I have my hand here. Do you think you
Heaven
could
to Betsy.
see
There it
my
is.
hand?
And I can see the warmth from her hand. That's actually glow from her hand. And she takes it away. We can see where her hand was. Fantastic. In the next segment, we're going to look at how this thermal radiation is responsible for heating and cooling in the Earth system.
Sounds great.